Hello guys, Assalamualaikum. Welcome back to my channel. So now we're gonna continue our discussion again. We're still discussing ACS exam in topic stoichiometry right now. So in the previous video, we discussed about the stoichiometry, and then still same now, still stoichiometry, but we are in the we still trying to solve number 11. Okay, for the last part is number 11. Okay, so for the last part. Okay, now we're gonna do for question number 11. What mass of SPF 3? Okay, SPF 3. Wait, where is the what mass of SPF 3 is needed to produce 100 gram of freon 12 CCl2F2, and then this one is the balance, the chemical, the equation. Okay, for number 11 is the equation. Okay, so let's walk through this step by step. Okay, for the first step is convert. Okay, for the first step is convert grams CCl2F2. Okay, so moles is 1 gram. So from here, 1 gram over 121 gram per mole. Okay, and so the answer is 0.00826 mole. Okay, and then again we have after that we use the mole ratio from balance equation. Okay, we're gonna use the mole ratio using the balance equation. Okay, so regarding the balance equation, we get something like this, right? 3CCl2F2 plus 2SPSCl3. Okay, so as you can see, 3CClF2, this one, okay, this one, okay, are formed from SPF3. Okay, CCl, this one, sorry. So this coming from this. Okay, okay, so CCl2F2 are from 2SPF3. Okay, so how to get that one? So as you can see, the SPF3 is this one, and then how to get that one is small. Okay, SPF3. So what's the mass, okay, that is needed to produce blah blah blah. Okay, as you can see, this one is 0.00826 mole. And then how about this one? Like I mentioned, if 3 produce 0.008 to 0, how about if 2? How about if 2? So over here we can get the 3x and then 2 times 0.00820. So we getting ended up for this one is around 0.00551 mole. Okay, in this case we still have in mole unit. We need to convert it into gram. Okay, so how to get that one is very easy. Gram is molar mass. Okay, mole. Okay, mole times molar mass. Okay, so which is 0.00551 times 179. So it will be give us around 0.986. So the answer is should be B. It's pretty easy. So just remember, we need to take a look at which one that we know from the equation, and then use the mole ratio from the Pelland's equation. Okay, now move on to another part, number 12. All right, for number 12. Okay, how to get number 12? Okay, let's take a look at what is the theoretical yield of aluminum chloride that could be obtained from 6 mol of barium chloride and excess aluminum sulfate. Okay, this is the equation. Al2SO4 3 plus 3PaCl2 being 3PaCO4 plus 2A aluminum Cl3. Okay, let's explain this one. This is a classic limiting reagent. Okay, like limiting reagent becoming product. Okay, stoichiometry question. So we are given like 6 what's the 6 mol of barium chloride. Barium chloride is over here, 6 mol. Okay, 6 mol. And then excess aluminum sulfate. Excess aluminum sulfate is the, which is excess aluminum sulfate. This one is excess. So regarding this information, this one would be limiting reagent or limiting reactant. Okay, whatever. Okay, we want the mass of AlCl over here. So first of all, please you try to determine the limiting reactant first, and then because we want to use the mole ratio based on the limiting reagent. And then if there is a kind of like clue in the equation, okay, if there is a clue in the equation kind of like excess, so it will be the another molecule, another compound will be the limiting reactant. Okay, so regarding that information, we see this one, if three producing 6, how about if 2? Okay, 2 will be what? 3x and then 12. So x, it should be 4. Okay, so over here it should be 4 mol. Okay, now the question is, what is the theoretical yield of aluminum chloride that could be obtained? Okay, what is the theoretical yield? Okay, how to get this one is very easy, because we already get the mol. Just convert this mol to gram. Okay, so like, what's that? Gram 4 times what? 133.3. Okay, so the answer will be 534. 534 gram. Okay, so the answer it should be C. All right, so we done for this question again for number 12. All right, so now is number so just a tip for you guys. When a reactant is in excess, focus all your attention on the limiting reactant. Okay, so again, when a reactant is excess, focus all your attention on the limiting reactant, and then after that use the mole ratio, then convert it to getting mass. Okay, don't jump straight to grams directly, but remember, okay, But however, this question is pretty easy as long as we can understand. So whatever question in stoichiometry, we need to determine the limiting reactant. So if we already got this information, it will be easy for us to determine for the further question. Okay. So now we are moving to another question. So a self-contained breathing apparatus uses potassium superoxide (KO2) to convert carbon dioxide and water in exhale air into oxygen. Blah 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 blah. Don't worry about, don't be upset because of the question. Just focus on for the number, the value of it. So how many molecule oxygen gas over here, how many oxygen will be produced from this carbon dioxide is coming from here, exhale in typical breathe in excess CO2 and water. Is actually for this one is pretty easy. Okay, so we are asked how many molecules of O2 can be formed from 0.0468 gram CO2, assuming KO2 and H2O are in excess. Okay, assuming both are in excess. So we don't care H2O, we don't care as well as KO2. Okay, now the first step is convert gram CO2 into mole CO2. It's very easy. Just 0.0468 gram over what for the number the the molar mass is 44, so the answer will be 0.001063 mole CO2. Okay, now take a look at the coefficient over here. So in CO2, let me think first. Okay, in CO2 is 4. Okay, for CO2, okay, for CO2 we get this one. Okay, we get this one, or I just want to writing down properly. So let's make it more organized. Okay, so how to get that one? Let me think. Okay, if 4 brought to 0.00163, how about if just 3 for O2? And then we will get ended up for this one is 0.0000790 mole O2. Okay, now step 2 is the second step is we need to convert to Avogadro numbers. Okay, just is pretty easy. How many molecules? So how many molecule is number of molecules? Okay, number of molecules and mole, okay, time 6.022 10 to 30. Okay, 10 to 30. So the answer will be around 4.8 times 10 to 20 molecules. Okay, so the answer is it will be getting added up. We are getting like the added we are getting the answer is 4.8. Okay, the correct answer will be A. So when asked for molecule, go from grams to moles, mole ratio, and then using Avogadro's number to determine to get the like the how many like the how much how many molecules, okay, or like the number of molecules in your sample. All right, okay, let's move on to another question again. Okay, let's move on to another question again. Okay, I need to get a water, guys. Yeah. All right. So now move on to another question again. We are trying to the getting the answer for another question. Right. Let's take a look at another question. Okay. If 365.5 gram H2O is combined with excess KO2, what mass of O2 is expected to be produced, right? So, regarding this question, 300 blah 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 is combined with excess KO2. Remember, there is a clue over here that which one that excess, okay? KO2. So, it will be this one becoming it will be this one being more like what's that, the limiting reactant, okay, limiting reactant. Okay, now we need to take a look at one by one. Okay, H2O, then the total of H2O is 365 gram. Okay, so now we need to get mole of H2O divided by 18.02. We ended up getting 20.28 mole H2O. Okay, so 2 over here, and then what's the question is mass of O2, mass of O2. So if 2 is 20, okay, if 2 is 20.28, how about if this one is 1? Which means from 1 over here, 1, okay? How about that one if O2 is just 1 for the coefficient? So 2x, 20.20x, so x, it will be what? 10.14 O2 mole O2. Okay, mole O2. Now just convert it into gram. It's pretty easy. Just 10.14 mole O2 times what? 32 gram per mole. We cancel out the unit, and then we getting ended up kind of like 324.7. So the answer should be C. All right, we done for this question. I think stoichiometry, especially for the reaction, is kind of like not, I mean, not too complicated rather than the previous one. For the moles and after like other things, is kind of like, is this one is like much more easier rather than the previous topic, okay? Which mean counting about moles and then molarity and then whatever it is, okay? So again, number 15. How many water molecules are produced if 0.34 mole of propane combust in excess oxygen? So oxygen is excess, and then the question is about how many water molecules are produced if propane, this is the propane. Okay, so let's take a look at for this one. Okay, it's still same, the principle is still same. We are told like the step 1 is still same, use mole ratio, how to get the mole ratio over here. It's like one propane and then for what's the mole over here? Okay, the propane itself is 0.34 mole with the coefficient is 1. Okay, how about if the H2O is 4? So just kind of like, because this one is limiting reactant, so it will be times 4. How much it is? 1.36 mole. And then the question is how many water molecules? It's pretty easy. Just using the Avogadro's number. Again, number of molecules. We will get like 1.36 times what? Times 6.022 1023. So it will be 8.19 times 1023. So the answer will be C. Okay, it's very easy, right? All right. So now move on to another part. We are in the, we are drawing for the next question is we still have same thing. Okay, we still have same thing. Okay, so most of the question is about like count like we are asked about how many uh like mass of like certain molecule or certain compound produced or something like that using the like basic of stoichiometry. Basic stoichiometry. It's not complicated. Okay, it's not complicated. Okay, what is the maximum mass in gram of NO2 form when 7.5 gram of N2O what this one? NO N2O5 is consumed. Okay, so let me check for the previous question. Do we get a like correct answer? Number 14 is C, number 15 is C. Yeah, that's great. That's great. There is no mistake. Okay. Now, what is the maximum mass in NO2 form? It's still same. Still same. The concept still same. Right now, we need to determine, okay, this one, we need to convert it into moles, okay? 7.5 gram over what it is, 108.0. So the mole, it will be getting ended up 0.0694 mole, okay? N2O5. All right. And again, we can use the mole ratio. Mole ratio. So from the balance equation, okay, as you can see, N2O5 it consists of two, okay? It has two coefficient. Uh while for what's the question? While for the NO2 it has 4. So we need to just times 2, okay? Use this one is 2 with the coefficient 2 and 205. So mole ratio over here is kind of like 2, so we need to just time 2, okay? This one is times 2, okay? Because of what? Because the 4NO2 it consists, it has 4, while N2O5 it has 2. So we have just like times 2 for this mole. 0.0694. So we getting ended up kind of like 0.1389 mole NO2. Now we need to determine the maximum mass. Okay, the maximum mass. Just convert it. Okay, convert to gram into convert mole, okay, to gram. So it's pretty easy. 1.389 times what? 46. So we get like 6.39 grams. So the answer it should be C. Okay, guys. All right, so now we are moving on to another question. Okay, question number 17. Mass of tin produced. Okay, what mass of tin is formed by the complete reaction of 1.75 mole hydrogen with excess tin dioxide? Okay, so from here, it's still same. From the balance, 1 mole CnO2, it's same with the 1 mole Cn or tin. Okay, so this one is 1. Okay, and then this one is also 1. So how we know this one is 1 is using the coefficient. Okay, coefficient E here is representing the mole. Okay, can represent the mole of that compound. Okay, so if we have like 1.75 mole H2, and then how about Sn? Okay, how about Sn? As you can see, the coefficient of H2 is 2. Okay, and then for Sn itself, it's just 1. Okay, H2. Okay, and then for Sn, it's just 1. So regarding this information, we can know that if 2 produce this mole, how about if 1? So it's pretty easy for us to determine okay, to determine Sn. Okay, to determine Sn, so it will be how like, let me calculate first, guys. Let me calculate first. 1.75 divided by 2. Okay, 0.875. This is for tin. And then how about the molar mass? So the question is about mass. So it's pretty easy. 0.875. This is gram. And then this one is 118.7. So now just times what? 118.7. So the answer, it should be 103.86. So it will be A for the answer. Okay. Right. Now move on to another question. So the answer is should be A. Yes, that's correct. And the previous one is C. Yeah, that's correct. What mass of FES is necessary? Okay. What mass of FES is necessary? Okay, so what the mass of this compound is necessary to form 1.08 gram of Fe2O5 with excess O2. Okay, the question is what mass of this one to form what mass of FES is necessary to form this one. So how to tackle this problem is pretty easy. As long, okay, we're gonna pause first. Right. So now we continue our discussion, guys. So what mass of FES is necessary to form this one? So how to tackle this problem is pretty easy. So now we need to convert Fe2O5 to moles, okay, into moles. So because this one is the information is gram, we need to convert it into moles. And then regarding this information, we know that just using the like moles over here, gram per molar mass. So gram is what's the gram is 1.08, right? Over 159.7. So the answer of this one is 0.00676. Okay. So and then we already knew about how many moles of this one, and then as if we are looking at the coefficient here, it has 2, right? And then the question is fes it has 4. So based on that information, we only need to times 2 for this mole. Okay, so just 0.00676 times 2. Because of what? Because it's just it for 2 Fe2O5, but we need to know for 4 FES. The coefficient is 4. Now we ended up getting 0.01352 FES. Okay, so based on this information, this is the mole of FES. Okay, and then we need to convert it into gram. It's pretty easy. Now is gram is 0.01352 times what? FES is 87.92. So the answer will be 1.19 gram. Okay, so the answer is 1.19 gram. All right. So yeah, always use mole ratios from the balance equation, and then convert back to mass or molecules depending the question. Okay. Okay, now it's a little bit different right now. okay, from the previous question, because we need to determine n. But I think still same concept, not much more different. Still same concept, because now we need to find the value of n. The value of n. Okay, the value of n. So we need to understand, we need to calculate the mass of water loss. Okay, okay, let's take a look at detail of the question. A 2.32 gram sample of Na2SO4 and H2O yields this one upon heating. Okay, and then this is the balance questions. Okay, the balance question, the balance equation. So now we need to determine from this one, 2.32 gram sample of this one yield this one. Yield this one. Okay, now how to like we need to determine like the mass of water loss. Okay, so if you are looking at this part is hydrate. Okay, hydrate. So we need to, the first step one is we need to calculate the mass water loss. The mass of water loss. How to get this one is just hydrate minus unhydrate. So 2.32 minus 1.42. So it will give us 0.90 gram H2O. Okay, it will give us this one. Because as you can see, over here there is no like another reactant, okay, another compound. Okay, there is no like kind of like reaction, just like heating stuff. Okay, heating stuff. So first of all, like initially we have this, and then at the end we getting, eventually we getting this mess for the final product. Okay, for the final product. However, there is also like side product, which is H2O. So as we know from this calculation, H2O is 0.90 gram H2O. Okay, so the question is, what is the value of N itself? Okay, now we already have this one, gram H2O. Okay, 0.9. We need to get the mole first. Point over 18. So the answer is will be 0.04995 mole H2O. Okay, we can understand from here. While for Na2SO4 we can getting 1.42 gram, and then we need to determine for the molar mass of this compound. Okay, so 142 I already calculated, so the answer is 0.0099. Okay, so and then we need to find the mole ratio. We need to find the mole ratio. Okay, so we need to determine N, right? But we need to determine for mole ratio. Now N is mole of H2O, okay, over mole Na2SO4. Why? Because all of the, I mean, because of what? Because we need to because this, adding this, it will be this one. So we can do like comparison or make it ratio. Okay, so mole H2O is 0.0499 and then 0.0099. So it will be giving us 5 for the answer. So the correct answer will be C. Okay, the correct answer will be C. So for hydrate problems, subtract to get water, okay, convert both to moles, and then find mole ratio of water to salt. Okay, water to salt. Remember, if you are getting question about hydrate problems, we need to determine how many like water that lost. Okay, how many water lost. Okay, how many water loss, and then we already get the water, right? Subtract from was that subtract from to get water. Okay, and then we need to convert both values, okay, salt and then water, to moles, to find the mole ratio. Okay, to get the mole ratio, okay, then find the mole ratio of water. Remember, water over salt. Water over salt for hydrate problems. It's pretty, I mean, it's very, very important. It's crucial because we don't have any kind other information rather than like kind of like we have to like we must know this information. We must know this information. Like mole H2O over mole of salt. Okay, mole of salt. All right, this is for hydrate. Remember, for hydrate question. How to know we get the hydrate over here. There is H2O, and then we have H2O as well. Okay, from here we can recognize this one is hydrate reaction, hydrate equation, sorry. Okay, number 20. A mixture of 9 mole F2 and 4 mole S are allowed to react. How many moles of 2 remain after 3 mole of S have reacted? Okay, a mixture of 9 mole, so 9 mole, so the balance equation is 3F2 plus F being SF6. So as you can see, F over here is 9, and then S also 4. Okay, S also 4. How many moles of F2 remain after 3 mole of S have reacted? Okay, so how to do that is very easy. We need to determine limiting reactant and leftover reagent. Okay, leftover reagent. Okay, each mole of S requires 3 mole of 2 according to the balance reaction. Okay, how much F2 is consumed? How many mole of, so we need to know how much is consumed first. Okay, so as you can see from here, if 3 mole already reacted over here, okay, if 3 already reacted over here, and then as you can see the coefficient is just 1, and then we just write it down over here 3, because this is like that which one we can like this is the initial, and then this is the reaction. In Indonesia we call it mula-mula, reaksi, and then hasil, ya, sisa. But over here I just want to say this one is like initial and then reaction, and then after that like product. Okay, product. So how many mole of sulfur that react, okay, have react over here is 3, right? However, the coefficient is just 1. So when we put it over here, if we have like 3F2, so it will be 3 times 3, so it will be 9. Okay, and then how many moles remain of F2? It should be Z0. Okay, it should be Z0. It's already run out. Okay, remember, when one reactant is an exact stoichiometric proportion, the other is completely used up. Okay, just multiply the moles of one reactant by its ratio to the other. Okay, because this one is 1, just times. Okay, something like that. All right, so we have to type like a new type. We have 2 new types question over here. For the previous one, we are asked about was that the hydrate problem, hydrate question. And then for number 20 here, we are asked for limiting reagent, and then like which one that completely used up, which one that still remaining, something like that. Okay, now move on to another question for number 21. Number 21. Okay. Number 21. What is the maximum amount of ammonia that can be produced when 0.35 N2 react with the 0.90 mol H2? Okay, what is the maximum amount of ammonia that can be produced when 0.35 mol N2 react with this one? Okay, let's rewrite the balance equation. Okay, so now determine the limiting reactant. Okay, determine the limiting reactant first. Okay, we compare what we have to what the reaction needs. Okay, remember, we compare what we have to what the reaction needs. Okay, the equation tell us that 1 mol N2 react with the 3 mol H2. Okay, and then it brought when, okay, we just want to writing down over 0.35, and then H2 is 0.90, right? Okay, but we only have 0.90 mol H2, which is less than required. Okay, so let's take a look at for this one, how to get the limiting reactant. Okay, how to get the limiting reactant. Okay, 1 mol N2, okay, will react with 3 mol H2. Okay, I will restate again. I will repeat it again. 1 mol N2 will react with 3 mol H2. Okay, so 0.35 mol N2 needs what? Needs what? Needs 0.35 times 3, 1.05 mol H2. Okay, so to get this one done, I mean, to get this one completely used up for N2, H2 should be at least 1.05 mol H2. However, we only have 0.9. Okay, we only have 0.9, which is less than this, which is which is less than required. Okay, which is less than required. Therefore, we can determine the limiting reactant over here. Which one that completely use up? Which one that completely runs out? Okay, so the first compound that will be run out over here is H2. So H2 will be limiting reactant. Okay, just remember, this one is very important to determine which one that limiting reactant, because there is no clue, kind of like the previous question. We have clue for the excess. Okay, we have clue kind of like the excess, but for this question there is no clue. Okay, it's just say, okay, we have this one and this one. Okay, and then we need to determine which one that use up completely first. Okay, so H2 will be used up first. Okay, and then we can use the mole ratio to find out NH3 from H2. All right, so over here, for if we have 3 and then 0.9 T, how about if 2? How about if 2? So for X, for mole, is kind of like 0.60. All right, that's done. That's done. As long as we as long as we getting correct answer, I mean getting correct limiting reactant, so of the limiting reactant, so it will be I mean the answer will be correct as well for the another part, okay? But however, if we are having trouble, I mean we choose the wrong limiting reactant, and then we will get wrong for the for the result, for the end of result. Okay, just quick tip, guys. When given two reactants like this one, N2N3H2, always check first which one runs out first using molar ratio. Okay, using mole ratios. That's your limiting reactant. All right, so yeah, that's very good. That's very useful information. Like I mentioned, as long as we choose the correct limiting reactant, it will be great for the for the left of process. The left process will be easier for us. Okay, now again, number 22. Equimolar amounts of nitrogen, hydrogen, and argon are placed in a reaction chamber, the amount of which substance will determine the amount of ammonia produced in the reaction below if the reaction goes to completion. And then blah 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 blah. Okay, the question is what? Which substance limits the NH3 yield? Okay, so you are asked N2, H2, AR or argon are all present in equal moles, okay? In equal moles. All of them in equal moles. However, remember, those compounds have different kind of coefficient, okay? And then remember again that argon is noble gas. Argon is noble gas and does not react. Okay? So the actual limiting factor, like the actual limiting factor depends on reactive species, whether N2 or H2. Okay? Based on the equation balance, 1 N2 will react with 3 H2. Will react with 3 mole H2. If you have equal mole, says it's just 1, okay, of each them of each, okay, 1 and 1, which one, okay, which one that will be completely run out? Okay, which one that completely run out first? Okay, so you have two little H2 over here. So you have to little H2 for each mole N2. As you can see, 3 H2 has 1, which is telling us, okay, if we have 3, if we have 3 people, but the cookies is only 1, okay, the cookies is only 1, so for each person will be eating like smaller pieces, isn't it, right? Okay, so regarding this illustration, we can assume, okay, so it's too tiny, it's too little H2, okay, the cookies is too small. All right, however, for N2, it's just one person, and then he has one cookie. Okay, which one that will be completely run out first? Which one that completely ran out first? The three person or one person? Exactly. Which one is 3% first? So we can determine which one that completely ran out first. It should be hydrogen. So the answer is should be hydrogen. Okay, the question is the amount. Okay, the question is okay. The amount of which substance will determine the amount of produced in the reaction. Okay, so which like the reaction goes to completion. So which one that complete first? Like I mentioned, it should be hydrogen. Okay, ignore K. Just focus on reactive component and their moles ratios over here. So the answer will be B. Again, number 23. How many total molecules will be present when the reaction 5,000 molecule of CS2 with 15,000 molecule of O2 goes to completion? Okay, as you can see, CS2, 3O2, CO2, 2SO2. So we have 5,000 over here. And then CS, and then O2, it has 15,000. Okay, goes to completion. How many total molecule will be present when the reaction, blah, blah, blah. All right, so wait, okay, how many total molecule will be presenting? Okay, guys, so over here, over here, the ratio kind of like same, right? The ratio kind of like same. Okay, so like I mentioned, the ratio will be same, so 5,000, and then this one is also 15,000 because it has 3, right? And then over here will be 5,000 because it's only have 1. And then how about this one is 10,000. Okay, so the total of molecule will be percent. Okay, how many total molecule will be percent? It will be like 15,000. Number 23 is C. Okay, use kind of like this concept. Okay, again, number 24. What amount of excess reagent remains when 0.30 mole NH3 react with this one, produce NO and H2O? Okay, again, rewrite the equation, balance equation first. All right, what amount the excess reagent remains when we have over here 0.30 and then react with the 0.40? Okay, which one? What amount of excess reagent remains? Okay, so we need to get the mole, like the mole ratio first. Okay, the mole ratio first over here. Okay, like I'm like my illustration, the previous illustration, guys. So like I mentioned, if 4 people getting 3, like for 1 people getting 1 cookies, and then 3 people getting 1 cookies. Okay, 1 cookie. So which one that run out first? It will be 3. Okay, it will be for 3 people. The same concept over here, but now we kind of like different kind of amount. So we need to find, I mean, we need to calculate manually. I mean, we need to calculate for the ratio itself. Okay, so which one that's smaller? 4. Okay, 4, let me think. Okay, 0.3 for what is that one? Okay, let me calculate first. Let me calculate first. 0.3 of 0.3 divided by 4, so it will give us 0.075, and then 0.45. Let me calculate again. 0.4 divided by 5. So 0.08. So which one that smaller one? The smaller one is this one. Okay, so it will be O2 is limiting reactant. Okay, limiting reactant. So let me think first. We need to determine the limiting reactant first. Oh, which one? Oh, no. Not this one, the smallest one. The smallest one is this one. Okay, I'm so sorry. So the only this one, the smallest one. Okay, not this one. So this is for NH3. This one is 4O2. Okay, so now we just plug over here for the reactant. Okay, so 0.075 if we only have one. Okay, and then we put it over here like 0.30. It will be used up completely first, and then 0.075 times 5. How many? This one 0.075 times 5. So this one is 0.375. Okay, now the question is like what amount the excess reagent remains. So which one that remains, we can see the remaining one is this one. So based on this information, it will run out for NH3. And then how about for the O2? O2 still have some. So 0.025. Okay, which one it is for O2? So the answer will be D. Okay, the answer will be D. Is very, very easy. It's very easy if we know the concept, how to solve this problem. Okay, number 25. What amount of Al2O5 is produced from the reaction of 3 mol Al aluminum with 2.0 mol Fe2O5? Blah 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 blah. Okay, sorry, this is not O2 O5. I think it should be O3, right? O3, yeah, it should be O3. Sorry. Okay, what's the amount of this from the reaction, this one and this one? So 3 mol aluminum is 3, okay, Fe2O3, Al2O3 to Fe. So this one is 3, and then Fe2O5 is 2. And then again, we need to determine the limiting reactant first. Okay, still same. We need to determine the limiting reactant first. So which one is limiting? Which one is limiting? Okay, based on this information, guys, we can see that like this part. Okay, just use kind of like this one and then try to find out which one that the smallest. Okay, how like 3 for we can do over here again for Al is 3 over 2, so it will be 1.5. How about the Fe2O3? 2 divided by 1, so it will be 2. Which one that the smallest one is? This one, Al. So Al will be the limiting reactant. Okay, now we just do the we just plug this number. Okay, this is should be 3, and then this one is should be what? 1.5. Okay, 1.5. What's the amount of ALO3 is produced? Because this one is only 1, the coefficient only 1, so we put it over here 1.5. This one is 3. So it will be ended up getting 1, and then there is a remaining reactant like the excess reagent, kind of like the previous question. So it will be 0.5 mol, and then over here 1.5 mol. So the answer will be 8. Okay, again, number 26. what amount of the excess reagent remains when 0.5 mole lithium reacts with the 0.350 mole N2. As you can see, guys, 6 lithium plus nitrogen will give the product to Le. What's that one? Le3N. Yes. Yep. What the amount the excess reagent? Kind of like same. Okay. We react 0.5, and then how about the N2 is 0.350, and then we need to determine the limiting reagent again, limiting reactant again over here. Which one that the smallest one? So for lithium, like 0.5 over 6, where N2 is 0.350 over 1. Okay, so it will be lithium, right? It will be lithium becoming the limiting reactant. I'm pretty sure it will be lithium, but I need to calculate first to be sure we got the correct answer. 0.5 over 6, so we getting ended up 0.083, and then this one's still the same, 0.350. All right, so we have the smallest number over here for lithium, and then what amount of the excess reagent remain? Okay, remain. So it will be 0.5 over here, and then we need to just times, okay, the previous like this amount times 1, 0. What 0.833, right? So the excess reagent remain what the amount, okay, what amount? So it will be 7, right? It will be 7, and then it will be 6, and then 2. Okay, the answer will be 0.267 for N2. For mole and N2, the answer will be that one. Let's check it first for my answer, whether that one correct or not. Yes, oh, 26. Yes, B. Yeah, that's correct. That's correct answer. Which mean I understand completely for this question. Okay, there is no dot. There is no dot. There is no dot for this question. All right. Now we are moving on to another question. The combustion of C blah 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 is kind of like a little bit like it's kind of like blurry, right? I don't understand why it's blurry. The combustion blah 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 with O2 is represented by this equation. Okay, hopefully I put in the correct balance equation. Hopefully. The 26. Let me. Oh my gosh. I need to double check, guys. Let me open it first. Okay. Yeah, I got it. So 2C3H. How many this one? 8. Yeah, 8O plus 902. And then becoming 6CO 280 like H2O. And then how much of the excess reagent remains? Okay, what is the excess reagent and how many moles of that reagent remain? Okay, what is the excess reagent, and then still same, we need to determine a limiting reactant again. Okay, so just put in over here like 3 gram. See, for this one 3 gram. Okay, however, we need to find out for the mole. Okay, now mole of C3H8O is what? 3 over 60.1. So how much it is? So the answer for let me check it first. Okay, it will be 0.0499 mole. Okay, so put it over here, 0.0499. Okay, and then now let's take a look at another part. Okay, let's take a look at another part. How about the O2? O2, we have like 7. Let me think first. Okay, 7.38 over 32. So 0.2306. 0.2306. Okay, which one did the lowest one? Okay, which one did the lowest one? So like the previous one, for 2C3HO H, okay, like this way. And then how to determine 0.05 over 2. Okay, and then how about the O2? 902, it will be 0.23 over 9. Okay, so which one that the lowest one is? It's kind of like 0.0250. This one is 0.0256. Okay, slightly less. Okay, this one is was that the combustion of this compound is slightly less. So for the first one, I mean for this one will be the limiting reactant. Okay, so just plug over here for the number 0.0499, and then after that just use this number times 9. Okay, use this number times 9. Okay, to get this value over here. Okay, how much it is? So it will be 0.2246. So the answer is 0.006 mole O2. So the answer will be A. Okay, I mean, it's pretty exhausted when we are like dealing with this like kind of like this question. I mean, not difficult, but we have to be careful when doing calculation stuff. Okay, again, consider this reaction for the production of lead. What is the theoretical yield of lead that can be obtained by the reaction blah 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 and blah blah blah. Okay, let's take a look at one by one. 2 ppO plus pps coming 3 pp plus SO2. Okay, and then now we have this one, so it's kind of like 57.33 over what it is, 223.2, and then 33.8 over 239.3. Okay, to get the mole. Okay, to get the mole. So regarding this information, we can get the value of each the mole of each reactant. Okay, let me bring the equation first. Okay, so I need to do calculation again for this one. So let me open my calculator, and then 57.33 over to 3.2, it will be 0.256, and then again just using same thing to 3.8 over 239.3, so it will be 0.1412. Okay, so this one is 2 ppO, so ppO, it should be 0.256 over 2, and then pps, it should be 0.141241. Okay. This one is 0.128, this one is 0.1412. Which one did the smallest one? This one, right? So ppo will be the limiting reactant. So just after that, we just plug this number again, because this one is like like completely run out, so we have to put in 0.256 completely run out. However, pps still remaining, still excess over here. Okay, so the question is, what is the theoretical yield of lead that can be obtained? This one, the question is this one. Okay, so using the number of this one and then times 3, so we will get the mole of pb. Okay, how to do that is pretty easy, just using 0.128 times 3. Okay, so the answer, it will be 0.384 mole. And then we need to convert this mole into gram using the equation. Okay, mole and then gram per mR. So pp is 207.2 times what? 0.384. So we will get the gram. Okay, so times what? 207.2. so the answer, the mass, it will be 79.56. Is there any 79? Okay, 79, it will be C. Okay, it will be C for the answer. Probably I'm wrong. Just I need to take a look at the answer. Number 28, it's C. Yeah, that's correct. Right. What amount of excess reagent remains when 4 gram of zinc react with 2 gram of phosphorus? Again, through 3Zn plus 2P becoming Zn3P2. Okay? And then we have zinc over here, kind of like 4 gram. Okay, zinc. So 4 over 6339. This is number 29, right? Okay, and then how about the P? P is still the same, phosphorus 2 over 30.97. So we need to do calculation for this part again, guys. And then I already uh, find out for the mole of each part. So this one, it will be 0.0631, and then this one will be 0.0646. Okay, and then we plug over here. This is for Z and this is for P. 0.0. Okay, but now we need to take a look at in detail. Because of the coefficient over here is 3, we just like divide this number to with the the coefficient over here, and then this one as well, it should be 2, kind of like this way. So 0.0631 divided by 3, this one, it will give us it will give us 0.021, and then how about the another one? 0.0646 over 2 would be 0.0323. So it will be this one becoming limiting reactant for zinc. And then the question is, what amount of excess reagent remain? Okay, reagent. So the question is about 2p. Okay, let's take a look at the reagent 2p. Okay, so as you can see, guys, over here is should be 0.0631, and then again 31, and then this one 0.0646, and then we have to use this number times 2. Okay, times 2. 0.21 times 2. So it will be 0.042. So the answer will be around 6. It looks weird. Why? It looks so weird. Let me think first. Oh, the answer will gram. Okay, I thought that the answer it will be mol. Sorry. 62200. So this is the remaining reactant. Okay, the remaining reactant is 0.0226 mol. This is the remaining reactant. So, and then after that we need to convert into gram. Okay, into gram. P is what's that? The P is 30. Okay, so P, what is that one? P is gram per mole. Okay, gram per mole, and then gram. This is, oh sorry. So to get the gram, it will be 0.0226 times 30.97. Okay, so let me check for the answer. And then how much it is? 0.0226 times 30.97. 0.69. Okay, the answer is 0.69, or rounding that one to be 0.7 gram. All right, so the answer will be A. So let's take a look at the key. Yes. The last question of this section, which is stoichiometry. For the next part, we are discussing about solution, aqueous reaction part 1. So we will discuss topic in the next chapter. We want to cover like molar concentration, and then gravimetric analysis, and then reaction, and then like reaction representation and other stuff. So if you are looking at your textbook, there the chapter might be the name of chapter might be aqueous reaction. Okay, aqueous reaction. Okay, we will be good for the next step. Okay, because we kind of like want to solve all of them together. Okay, an initial reaction mixture O2F2 is shown on to the right, which representative shows what will be present after the reaction is complete. Okay, so an initial reaction mixture O2 is shown to the right, which representation show what will be present after reaction is complete. The question here is the reaction here is complete. Okay, just quick review that which one that will be running out first. Okay, which one that will be running out first? So assume everything 1 mole. Okay, everything one mole over here, 1 mole. Okay, so which one that might be run out first? Might be running out first. So as I mentioned, O2 we can do kind of like this way, 1 mole per 1 coefficient, and then this one. And then for F2 will be 1 divided by 2, so it will be 0.5. Which one is the smallest? The smallest is F2. So we can get that the F2 will be running out first. Okay, so over here we have the excess O2. Okay, excess of O2. Okay, so this one is 0.5, so it will be 0.5 for the excess oxygen, and then like kind of like half, right? And then for F2 will be 0, and then this one to OF2 it will be 0.5 times 2, so it will be 1 OF2. Okay, which representation shows will be present after the reaction complete? Let's take a look at for this one first. Okay, this is the fluorine is black, dot black. The oxygen is like hollow. Okay, based on this information, O2 will be still exist. Okay, should be still exist, as you can see. And then fluorine should be like run out, not there, no exist for fluorine. So take a look at one by one of the picture. Okay, all of them not containing fluorine. Okay, so which means all of them like possible answer, might be the possible answer. And then let's take a look at of oxygen. Which one that still exists? Just C and P, right? So it will be not the answer for A and T. Okay, C and P still exist. However, let's take a look at for the ratio of the for each compound. O2 only have half. Okay, O2 only have half, and then as you can see, it should be different. Okay, it should be different. So F, this one is OF2, right? Okay, this one is O2. Okay, O2. Okay, how many O2? O2 is 2, and then OF2 is 4. So it makes sense, right? Okay. So because O2 is half, and then OF2 is 1. So kind of like half of OF2. So O2 is 2, OF2 is 4. Okay, that's good. So the answer should be B. Alright guys, we finished for this concept. I mean for this section about stoichiometry. Okay, we wanna meet for the next session for, like I mentioned, aqueous solution, and then please still joining, I mean still like watching all of the videos. So I'm pretty sure we will pass for the test. Okay, thank you, bye bye for your attention. Assalamualaikum.